Good morning, guys. So we're going to be doing examples from this mole packet, starting with the first one. What is the molar mass of carbon dioxide CO2? So to find the molar mass, we need to add up all of these different parts. So when we look at our periodic table, each element, there's a number under it, which is the molar mass. And so we're going to be adding up all those numbers. So for CO2, C is 2.01 plus, we know oxygen is 16, but we have 2. So we're going to have to multiply that by 2, and you're going to get 44.01. So for the next one, what is the molar mass of potassium oxide, K2O? So we have 2 Ks, so K is 39.10 plus oxygen, which is 16. That's going to give us 94.2. So that's the molar mass of potassium oxide. Okay, for the next section, how many grams is 0.85 mole of potassium chromate, K2CrO4? So the first thing we need to do is find the molar mass in grams for K2CrO4. So we have 2 potassiums plus 1 chromate, which is 52, plus 4 oxygens this time, which gives us 194.2. So that's the molar mass of this. But they're only asking for 0.85. So we need to find what this is in grams. So we need to put moles somewhere where it will cancel out. So it cancels across. So I'm going to put moles on the bottom so it can cancel out. And what I don't want to cancel out is what I'm trying to find. So I'm trying to find what it is in grams. So this is how much is in 1 mole of this. So when we do that, that cancels out and we get 165.07 grams. So 165.07 grams is 0.85 moles of potassium chromate. Okay, so how many moles are in 15 grams of lithium? So we have 15 grams of lithium. We need to put grams somewhere where it'll cancel out and put moles somewhere, which is what we're trying to find, where it won't cancel out. So I'm going to put grams on the bottom. 6.94 grams is how much 1 mole of lithium is. So when you do this, that cancels out and you get 2.16. So that's how many moles are in 15 grams of lithium. So one more example for this question. You have 22 grams of argon. You want to put grams somewhere where it will cancel. So you're going to have to put it on the bottom. So this is how many grams. This is the molar mass of argon, and the molar mass is in grams. So when you do this, you get 0.55, and that's in moles. So 0.55 moles are in 22 grams of argon. For the next section, so this is the number of units in 1 mole, 6.02 times 10 to the 23. And units can be molecules, atoms, or particles. For this first section, it's asking for molecules, atoms, and particles. And for 1 mole of all these elements. And so it's always the same for each element. It's always 6.02 times 10 to the 23 units in 1 mole of, doesn't matter what element it is. And so that means the answer for all 3 of these will be 6.02 times 10 to the 23, because it's only asking for 1 for each one. And so we'll write this for each one and just replace it with the units. For the first one, number 1 will be molecules, 2 atoms, 3 particles. Okay. So let's do an example. How many molecules are in 1.3 or 1.3 moles of nitrogen dioxide. So they're giving us 1.3 moles of nitrogen dioxide. You need to find how many molecules are in that. So you want to put mole somewhere where it'll cancel out because we don't need it. So you put it on the bottom and put molecules somewhere where it won't cancel out, which would be the top. So when you do this, that cancels out and you're left with 7.8282 times 10 to the 23. So that is a number of molecules in 1.3 moles of nitrogen dioxide. Okay, now let's go to some hydrate problems. So here, working with hydrates, write the names of the following hydrates. So Fe is iron, and we need to include the Roman numerals because iron can have multiple charges. So we know it's 3 because there's a 3 there, and this is what it has to be to balance out. So when you do that, see, this is fluoride, and now 10 is deca, so you write deca, and then H2O is hydrate. That's how you write that. So for the second one, you have magnesium, which is Mg, SO4, which is sulfate, and then 6, which is hexa, H2O, which is hydrate. Okay, so write the formula for these hydrates. Lead is Pb. I like to write it first and then balance it after. So nitrate is NO3, and you have tetrahydrate, so you know it's 4, H2O. Now the charge of Pb is +2. The charge of NO3, so nitrate, is -1. So to balance it, you're gonna need 2 of this. So this is your formula for the hydrate lead to nitrate tetrahydrate. Okay, now let's go to some other hydrate problems. So for 22, 2.50 grams of blue hydrate CuSO4 x H2O is heated and then weighs only 1.59 grams. What is the formula of the hydrate? What number is x equal to? So, blue hydrate is this whole thing, and when it's heated, which means we're losing the water, we have this left, which would mean this is how much that weighs. So CuSO4 is 1.59 grams. Okay, we're going to convert this to moles. This is the molar mass of CuSO4. Okay? Okay, so to find how much water there is, we're going to take our total minus the one that's not the water. So 2.50 minus 1.59 equals 0.91. So that's in grams. So let's convert it into moles. 0.91 grams H2O. So 18.02 grams, 1 mole. Okay, so that's how much our water is in moles. Okay, so we're gonna write the ratio in a way that will let us find out what x is. So we know this is 1, so let's write it in a way that 1 is this, and so we can find out what water is. So I'm going to write it like this. I'm going to put our water on the top, our CuSO4 on the bottom, and that will give me 5/1. So 1 here, 1 here, 5 up here, 5 here. So that means our formula is like this. So it's pentahydrate. Like that. So what is the mass of our anhydrous sample in the above problem? So this is our water. So anhydrous means without water. So our water is heated. We lose the water. So if we lose our water, we're left with this, which is this. So mass of CuSO4 is 1.59 grams. Okay, what is the percent of water in the hydrate? Na2CO3 decahydrate. So the molar mass of this is, I calculated this beforehand, but you can calculate it by looking at the periodic table. And so for decahydrate, if 1 mole is 18.02, 10 will be 180.2. And these are both in grams. When you add it together, you get the amount in grams for this entire hydrate. So when you do that, you get 286.19. This is for everything, which means this is your 100%, because so you're 100% and you're trying to find the percent of water. So what is our water? Oh, this is our water. This is our water. So 180.2 grams. How much is that? Right? So when you solve for x equals and what you get is 62.96. So what this means is 62.96 water is our percentage of water in the hydrate. And that's it. Bye.